In this video, we're going to be looking at ultrasound. Ultrasound are sound waves that are over 20,000 hertz. And I haven't just plucked that number from anywhere. 20,000 hertz is the highest frequency that humans can hear. And since we seem to believe that the world revolves around us, that is how we define ultrasound. Frequencies higher than the human hearing range. So, why are ultrasound waves of interest to us? Well, we can take advantage of some of the properties of ultrasound waves. In particular, I'm talking about partial reflection. And to be honest with you, it kind of does what it says on the tin. When an ultrasound wave hits a boundary between two different materials, some of the wave gets transmitted through and some of the wave gets reflected back, hence partial reflection. So why is this a useful property of ultrasound? Well, you know those black and white pictures of unborn babies, where really they kind of look like blobs, but you have to kind of pretend that it sort of looks like a baby? Well, ultrasound is how we take those images. To be fair, the quality of the images has improved massively in recent years. So let's have a little think about how that works. Let's say you emit ultrasound waves through the mother's baby bump. Each time those waves hit a boundary between two different materials, part of the wave gets reflected back. So, for example, at the boundary between the fluid in the mother's womb and the baby's skin, part of the wave will be reflected back. Since we know the speed of these waves, we can use the time that it took the wave to get there and then get back to estimate the depth of these different materials. And by emitting multiple pulses in all different directions, we can start to build up an image of what the unborn baby looks like. That's how they're used for these ultrasound scans. Now, for a little bit more of a mundane use for ultrasound. Let's say you have a material like a metal pipe, and you would like to make sure that there are no cracks in your metal pipe. Well, you can use ultrasound to help you out. If you send an ultrasound wave through the pipe, then it should be reflected by the end of the pipe and make its way back to be received. If you get a wave which is reflected back sooner, then that indicates it was reflected back because of a crack in your pipe. That ultrasound wave met a boundary between the metal and the air. Okay, and our final use we're going to look at is sonar. And to be fair, this is a pretty cool one. Imagine you're in a submarine and you'd like to know how far down the seabed is. Well, you could send out ultrasound waves to help you. The sooner the wave gets reflected back, the closer you are to the seabed. Let's do a quick example. Calculate how long it takes for an ultrasound pulse to return to the submarine if the speed of sound in seawater is 1,520 meters per second and the submarine is 1,000 meters above the seabed. Okay, so we're gonna be using speed is equal to distance divided by time, but we've got to be a little bit careful. Our distance here is not 1,000 meters because the wave actually has to travel all the way to the seabed and back to the submarine to be received. So actually, my distance is 2,000 meters. So time is equal to distance over speed. 2,000 divided by 1,520 equals 1.3 seconds. Okay, hope you found that useful. Please make sure to download all the notes. If you like the video, please do give us a like and subscribe. Thanks for watching.